So to make sure everybody had a good idea of the game, we split up into different groups to read different sections of the game manual. So we split up into these different groups, and we had one person take notes for each group. Then that one person presented to everyone to make sure that we all had a pretty good idea of how the game was played and all of the different rules and restrictions that we would have to abide by for this year. So after we had a good idea of how the game was played and how we wanted to play it, we then made a list of our needs and wants, which Marvin will talk about.
Okay. So we started with splitting the list of priorities into needs and wants. Needs is things that we really need to be able to play competently in the game and to score like a minimal amount of points. Then wants is things to be able to score, to play more competitively and win more matches. So with needs, we started by saying we needed a drivetrain to be able to move around the field. Then we said that the fuel cells were the most important part of the game, obviously because they're the main game component. So we said that ball collection was the second most important, then scoring the balls, and then finally we finished with the ball hopper being at least 3, being able to fit at least 3 power cells, because that's the starting configuration amount. Then we moved over to wants and said that climbing was the next important because it has the highest amount of points for the effort put into it. Then floor intake, because we'll be dropping balls, or if the human player drops them and we aren't able to collect them in time, it's important to be able to collect from the floor. Then scoring in the high goal, because that's the next highest amount of points. And then finally, we looked at the ball hopper, which needed to be the full size to be able to fit all 5 possible balls allowed to be held, and the intake being on the opposite side of the scoring mechanism, because with that you don't have to be turning around with your cycles, and it cuts down your cycle time by a lot. And we said that the spin wheel was our last priority, because the amount of power cells needed to be able to score to get the spin wheel to be able to move the spin wheel was too much of the time, and we weren't going to get to that, and it's the last priority.
So by the end of the first day, we wanted to be able to have a driving chassis and a fully fleshed out design. Fortunately, we were able to do both of those, as well as a lot more, which was cool because we are ahead of schedule, which has never happened in the history of FIRST. I like the way that we were able to integrate the mechanism as like one system, as you put the ball in the back, you shoot out the front, so we never have to turn around. It makes driving really easy. We're still playing around with some stuff, but I think it would be cool if we could end up doing a batter shot where you just go right up against the wall and shoot straight up in the air pretty much. It makes aiming a lot easier, decreases our cycle time a little bit. Like I said, we were able to get a lot more done than we figured. We have a pretty much fully working shooter. We had to test it. There were some issues a little bit with accuracy, but we had some ways to fix that, implemented them, so we haven't been able to test those yet, but hopefully that'll work, just on centering the ball a little bit better and things like that. We got our intake working pretty much now. Yeah, basically we're way further along than I expected to be, and it's pretty cool. We are starting to mount stuff to the actual robot, working on all of the actual parts now. We're done prototyping, so by the end of tomorrow we should be good and have a fully built robot that we can start programming.
Yeah, so the designs we considered for Robot 3 Days this year, we had a couple different designs. They all kind of centralized around the same thing. They all kind of looked a little bit similar, so that's kind of what helped us drive our design. The design that we chose was pretty similar to last year's Everybot, made by Team FRC 118, the Robonauts. It was just a simple angled, hopper belt-driven mechanism that fed the ball from the floor up to the height where it needed to go to dump it into the cargo ship or whatever. So we just built on that sort of concept of being able to store balls that way. We added a ground pickup to go over the bumpers to make the bumpers simpler to make. So we don't have any frame or bumper cutouts and frame cutouts, and then we also added a dual wheel, sideways wheels shooter at the top to just project the ball up to the high goal. We are in the process of also prototyping a climber too. With our shooting distance, we kind of The shooter is really designed for being able to be easily change an angle and pitch of your shot. So right now we have a pivot point towards the back of the robot, and really what we plan to do is mount a bar to the front of the robot, to the angled hopper and shooter, in order to find out our pitch. And when we're testing out and finding the angle we need to be at. We're originally trying to get to the shoot from the white line. We might shoot from the protected zone at the driver's station, based off of it might be easier, more accurate and reliable, since we could touch into the wall every single time and use the wall to line up. Just out in the open with the shooting off the white line would be beneficial for auton immediately, but other than that, it could be a little bit harder during the match. We were thinking about possibly using a flashlight to help with targeting, since we don't have enough time to implement vision software.